Still exercise 406, comparing data sets using box and whisker plots at the moment, all right? So looking at the 2006 HSC question 24, it says the heights of 60 members of the choir were recorded in this grouped. They were grouped, the results were grouped and displayed in this cumulative frequency histogram and polygon. If you look at the numbers at the bottom of the columns, it's got 145, 155, 165. They are actually class centers. It says, so 145 is the center of the first column. It says the shortest person in the choir is 140 centimeters and the tallest is 190. So that means here is 140 and up here is 190. What do you think this is, where I've got the next arrow? 150, etc. In other words, the first column goes from 140 to 150, but the class center is 145. Because if you add 140 and 150 together and divide it by 2, you get 145. The next column, this edge is 160, 170, 180, etc. Okay, so we have to keep that in mind. Now the question is to draw a box and whisker plot that relates to that data. Okay, now how many scores do we have? When you don't know the actual scores, you don't go 60, I'm going to put 30 to the left, 30 to the right. We don't do it like that. We've got 60 scores. That's the 100% mark. So to get my median, or I can do my first quartile, you know, Q1 is at the 25% mark. So I do 25% or a quarter of 60. Do you get it? Because we've got 60 scores. So I've got 25% of 60. I come across at the 15th score. I come across at the 15th score. It is not that the first quartile is 15. So I'm going to go halfway between 10 and 20, do my dotted line and come down. And look, that's pretty much sitting at, what's your first quartile, do you think? Yeah, I know my thing's a bit crooked here, but it is. So Q1 I've got is 145. The second quartile, which is called the median, is at 50%, 50% of 60. I come across at the 30th score, the 30th score. It's not 30. I come across at the 30th score. Now this one seems to be on the border. And we already defined what the border was. What is the border? 150. So the median is 150. Right, Q3 we come across at the 75% mark. So 75% of 60, or 3/4 of 60 is the 45th score. It's not, so the actual Q3 is not 45. We come across the 45th score. I think it's on the border again. Yeah. And what is that border? 170. Excellent, 170 for Q3. Okay, now, in the question, remember, a box and whisker plot has 5 bits of data in it. The lowest score, the highest score, etc. What is the lowest score? 140. All right, and the highest is? So lowest score is 140. So the lowest score is 140. And we know the highest person or the highest score is 190. They already said that in the question. They said the shortest person, is 140. And the tallest person is 190. So the box and whisker plot, what do I plot first? The lowest score. All right, I have to go from 140 to 190. We're either going to jump up by 10s or we're going to try and jump up by 5s on this scale. All right, let's see what we can do. If I go 140 here, let's just see if it works. 140, 150, 160, 170, 180, 190. Great, it fits. So you would do that. 140, 150, 160, 170, 180, and 190. And now let's put all our data in. Hopefully everyone's got all that. Okay, so 145 is the lowest score. Put a dot. The highest score is 190. Put a dot. Just make sure they're level. The Q1, I've made a mistake. 140 is the lowest, Q1 is 145, so we put that line for the beginning of the box. The median's 150, so we put a line. It's got to be the same length as the other one, all right? We'll even it up in a minute. Q3 is 170. Remember, the box is the interquartile range. So I draw my box between those, and you'll have to fix the heights up a bit. And the whiskers go out to the lowest number and the highest number.
Yay.
And there's your box and whisker plot. Okay? So it needs to be accurate. All right? There's your middle 50% of data. So we've got the lowest score, we've got Q1, we've got the median, we've got Q3 there, and we've got the highest score there. Remember how you've got those 5 essential, your 5-number summary, your 5 important pieces of information. Lowest and highest, Q1, median, Q3. Median is really Q2, by the way, the second quartile. English and maths for a class were recorded and displayed in this box and whisker plot. Look, you know this question, I think you can do that on your own. We did something very similar earlier. So you can check your answers later, but you can do the interquartile ranges. Do you know what to do? All right. And you can, let's just talk about skewness, but because you seem to be a bit, what do you think about the skewness? And guess what? Skewness is worth 3 marks. So compare the 2 data sets, actually, by referring to skewness and measures of location and spread. Now we're looking at 3 marks. So what do you think you need to be talking about? Yep. So this is what we want. We want positively, negatively skewed for each of them. We want the measure of location is mean, median, or mode. What can you tell from a box and whisker plot? Mean, median, or mode? So this is what we want to do. You need to talk about skewness for each. We want the medians for each. And measures of spread. What do you think would be better to talk about? Interquartile range or range? What's more accurate? Interquartile. You can briefly mention the range, but I'd be focusing on the interquartile range. Okay. So with this question, those 3 marks, I would, if I were you, underline skewness. Measures of location, that's triple M, mean, median, or mode. You can only see the median on this graph. Measures of spread, you're looking at range, interquartile range, standard deviation. Range is not very useful. Range includes outliers. If we can do the interquartile range, it's better to do that. So we would do interquartile range. See how part 1 leads you into it? It asks for the interquartile range for English. Can you see the interquartile range for English? What have you got? What's the yeah, so you can, we may as well do it. Interquartile range for English is 30. What about the interquartile range for maths? So interquartile range, let's just do this question. English is 30. Maths is what? Interquartile range for maths. What's that? 15. What does that tell you? Don't just spit out data. That's not going to be enough.
The scores are closer to
Yeah, you're going to say that the middle 50% of scores in maths, doesn't it look like the maths marks are a lot closer together for a start? Like, even if you talk about range, the range for maths is 40. The range for English is like, what, 85 or something. It's huge. But the interquartile range, but that could include an outlier. Do you know what I mean? Maybe one person got 10 only, and the others got from there. So you really don't want to be talking about range, because there could be outliers. But I'd be saying the interquartile range for maths is much smaller than the interquartile range for English, indicating that the scores are closer together in maths. So IQR for maths is smaller than IQR for English, meaning scores are closer together, meaning marks are closer together, in maths, or less spread out. Marks are less spread out, or closer together for maths, or that the middle 50%. Okay? Now, right, so more consistent, we could also say more consistent, all right? The marks are more consistent in maths. What about the median? So median for, which one's higher? Which median's higher? So median for maths was 75, approximately 75. And English, the median was 70, meaning that the performance in maths is slightly better, I suppose. Okay, so performance in maths was slightly better. Okay. And skewness now. This is the one that tricks everyone. Do you think, look at English here at the beginning. Are they spread out? That's 25% of the scores. Are they really spread out, those 25%? Yeah, they are. Most of the score, and these are more fairly spread out, but this bit here, the third section, is fairly close together. And I know that's a little bit big, but not too bad. Would you say most of the scores are at the beginning or at the end for English?
Yeah.
At the end. So it's positively or negatively? We're not starting on a positive, well, not that this is a positive thing. Better scores are better, but this is negatively skewed. The data, if I did do columns, yes. In 10 and 50. A quarter of the people got between 50 and 70. A quarter of the people got between 70 and 80. Isn't that a lot of marks in that small space? Yeah. And a quarter of the people got between 80 and 95, right? But same here, okay? Now, notice it's skewed. A lot of people are getting better marks. See, look here. Actually, I could even say, watch this. Look at maths. What percentage of the class got more than 75? Half. Half the class. Half the class got more than 75 here. Half the class got more than 70. But that's what the median is, you see. Tells you the halfway mark. But look, a lot of this is 25% of the people and 25% of the people. This is also 25% and 25%. These sections at the end here for maths are smaller than those two sections. So they're both negatively skewed, okay? But the data for English is much more spread out. So both English and maths have scores concentrated near the upper end. Does that make sense? Are negatively skewed. So both English and maths are negatively skewed. They've got scores towards, you know, the upper end of that scale. More scores. So more scores towards the upper end of scale. Okay, so they're skewed fairly similarly, but, you know, maths performance is slightly better, and I'd say maths performance is also more consistent because they're less spread out. So look how spread out the English performance is. So maths has a higher median, meaning performance in maths is slightly better, and also I would say that the maths results are more consistent. Does that make sense? Yes. To compare, let's say maths. What percentage of kids got 50 or more? What percentage of kids got 50 or more in maths? What percentage of kids got a mark over 50? All of them. The whole graph is over 50, 100% of the kids. What percentage of kids in English got 50 or more? 75%. All right. What percentage of kids, but, for example, in maths, got 80 or more? 25. Same with English. See? These are other things that we can say as well. All right? You know, so again, you know, where we've got the median for maths is 75 and English, the median is 70, performance slightly better than in maths. You could say also, not just that, but you could say 50% of the kids got 75 or more. Do you know what I mean? In English. And in maths, 50% of the kids got 70 or more. So performance in maths slightly better, and I could say 50% of students got greater than 75 in maths and greater than 70 in English. Do you get what I'm saying? So you can also, with your median, talk about percentages. With your interquartile range, talk about percentages. Why am I saying the performance in maths is better? Because half the kids got over 75 in maths and half of them got over 70 in English. So it doesn't, you know, it depends on difficulty of the exam as well. All right, but do we get that? So please use percentages as well. All right? Okay. Quartile range, that's very easy for the boys. You should already have the answer.
No. Yes? Yes. Oh, wait, no.
It's 6 minus 2. That one's easy. What percentage of girls spend 5 hours or less on the internet over the weekend? What?
25%.
Excellent. 25. Great. Now, this one's tricky. Jenny said that the graph shows that the same number of boys as girls usually spend between 5 and 6 hours. It's not the same number of boys. What percentage of girls spend between 5?
25.
So they're both 25%, but I don't know how many girls or boys were asked. So Jenny said that the graph shows that the same number of boys as girls spend between 5 and 6 hours on the internet over the weekend. Under what circumstances would this statement be true?
And circumstances that we know the population of both.
Yeah, but what if there were 40 boys being asked and 20 girls being asked? Would you get the same answer?
In case that they're both population.
So you'd have to have, must have the same number of boys as girls. Same number of boys and girls, or of boys as girls. Do you get it? Because let's say there were 40 boys and 40 girls. 25% of 40 means 10 people. For example, if there were 40 boys and 40 girls, we've got 25% of 40 is 10 students. 10 boys and girls. But if there are 40 boys and let's say 20 girls, we've got 25% of 40 is 10 for the boys, but for the girls, 25% of 20 is 5. So that is different numbers. Does that make sense? Okay? So the only way it's ever going to be true is if you've got the same number of boys as girls. All right? See question 29C. Terry and Kim each sat 20 class tests. Now, Terry's results are on the box and whisker plot at the top.
Oh, is that
You tell me, is that, yes, yeah, now, and Kim's 5-number summary is below, 67, 69, 71, 73, and 75. All right, girls, those 5 numbers are our critical numbers. Lowest score, Q1 is next, median, Q3, and the highest score. So Kim's lowest score is 69, and then her Q1 is 71, and then we've got 73, and then we've got 75. No, we haven't. Sorry, I've made a mistake. 67's the lowest, then 69, then 71, 73, and the highest is 75. So let's draw the box and whisker. Try and get that straight. I know my box is a bit bigger than the other one. Now, that look how each one's going up by 2. 67 to 69, 71, 73, 75. They're all jumping up by 2. That graph, if I put a line down the middle and I folded it in half, the left-hand side would sit on top of the right-hand side. It would fold directly on top of each other. That is symmetrical. So Kim is not positively or negatively skewed. Her results, they are symmetrical. So we've drawn the box and whisker plot. Right, that's the lowest score. That's Q1, median, Q3, highest score. What percentage of Terry's results were below 69? You should be very good at this now. What percentage of Terry's results? It's half. 25 and 25%, that's 50%. The 2 sections are 25% each. Now, Terry claims that his results were better than Kim's. Is he correct? Now, this is worth 4 marks. 4. Oh, Terry claims that his results were better than Kim's. Is he correct? Justify your answer by referring to the summary statistics and the skewness of the distributions. All right. What summary statistics can we look at? Well, yeah, there needs to be 4 somethings. All right, and you must answer. And, wait a sec, and is he correct with justification? So, is he correct? Let's start with a percentage. Tell me about half of Terry's marks were below what?
69.
And only a quarter of Kim's marks were below 69.
Oh.
That's, right, so that's one, all right, or only half. Even though, look, we do know that he did have a higher mark than Kim. Like he got 76. That's right. That's a really good thing to say. Is that, well, we could say that 75% of Kim marks are over 69, but only 50% of his marks are over. And this was 20 tests as well. You could actually say she did better in 5 more tests, really. Like, in a way, sort of. Well, you know, but I'd be very careful. But I would say so Terry achieved less than what? 69. See, you can't compare the mark of 68 for both people. Do you know why? Because 68 is somewhere between 67 and 69 for Kim, and it's not a specific cutoff point. All right? So Tim achieved less. Tim achieved.
Terry and Kim.
Terry. Whereas Kim achieved less than 69. I think it's just 69 in only 25% of her exams. Okay. Then we'll talk about the median. Summary statistics, guys, we're looking at measures of location and spread. If they wanted just measures of location, they would be very specific. So summary statistics, we're looking at mean, median, mode, but you can only do median here, or we're looking at range, interquartile range, etc. But we know that interquartile range is the better one to use. So that's a percentage sort of remark. We can say that the interquartile range for Kim is smaller. So what's her interquartile range? Interquartile range for Kim, which happens to be 73 minus 69, which is 4, is smaller than Terry's, which is 74 minus 68, which is 6. So you can actually put the working out. 73 minus 69 equals 4. So interquartile range for Kim, which happens to be 4, is smaller than the interquartile range for Terry, which is, his is 6, indicating Kim's performance is more consistent. Indicating Kim's performance is more consistent. So let's talk about median. I know we've done a percentage thing here, but we can also say that the median for Kim, which happens to be 71, is higher than Terry's median, which is 69. So we've got, and so we've got a measure of spread, we've got a measure of location, we've talked about some percentage things there, and we need to talk about skewness. So Terry's data. Yes. Yeah, that one. It's not too bad, though. Terry's data is positively or negatively skewed? It's positively skewed because 25% of his scores are down there. 50% of his scores are between 67 and 69. That's, yeah. So Terry's data is positively skewed, meaning there is more data at the lower scores, meaning more lower results. Does that make sense? Yeah. Whereas Kim's data is symmetrical, meaning a more consistent performance. Oh, yeah. I'd say that, meaning a more consistent, or more evenly spread performance. More evenly spread performance. So we could also say, even though Terry did achieve 1 mark higher than, even though Terry's, so we can say even though Terry's highest mark is 1 more than Kim's, Do you know what I mean? All of these points indicate that Kim's performance is better. So we can say even though Terry has the highest mark by 1, Terry has the highest score by 1, Kim's performance is better for the reasons above. Is better for the reasons above. For the reasons given. Distribution of ages of children in Numbertown in 2000 and 2010. Numerically, it says in 2000 there were 1,750 children. So in this year, 1,750 children in age 0 to 18. How many children were aged 12 to 18? Now look at 2000. 12 to 18 is what percentage of the scores? So what I'd be writing, that's 25%, 25%, 25%, 25%. I'd be working out what each section is. Like, so, but from 12 to 18, it's 50%. So 12 to 18 is 50% of the 1,750 kids. In other words, half of them, which is 875. Now, if there's 875 from there to there, can we do half of 875 as well, which is 437.5. Now, we know we can't do halves, but from there to there is 875. We okay with that? Yeah. All right. So those two sections is 8. Each section's about 437 or 438, right? The number of children, now part 2, the number of children aged 12 to 18, so the number of children aged 12 to 18 is the same in both 2000 and 2010. Now, how many kids here, 12 to 18? 20, yeah, it's 875 as well. But that 875 is only a quarter of the kids. You know, as time goes on, doesn't the population increase pretty much? This must be a city, not a country town, okay? So the same number of, the number of children aged 12 to 18 is the same in both 2000 and 2010. So there's 875 kids aged between 12 and 18, but that is only a quarter of the kids in 2010. So this section's 875. This section is also 875, and look how many babies there are. 875 kids aged between 0 and 2. So this must be, you know, an area where young families are going to and stuff like that. More younger families have moved into the area. All right, there's a lot of kids, a lot of babies. Okay. Well, younger ones. So, yeah. So now, remember, this whole graph was only 1,750 people. Well, now it's 875 times 4, which is 3,000 something. What's 1,750 times?
3,500.
Can you do 875 times 4?
Yeah, it's 3,500.
So it's double. The population's doubled in those 10 years. Can you see that? In that age group, 0 to 18. So it says how many children aged 0 to 18 years are there in 2010? Well, we just did it. It's 875 times 4, 3,500 kids. All right? Now, remember there were originally 1,750 kids. Now it's doubled. Identify 2 changes in the distribution of ages between 2000 and 2010. In your answers, refer to measures of location or spread or the shape of the distributions. You know what? It's worth 2 marks. You've got to at least say 2 valid, different points. So what do you think's happened? Well, let's talk about skewness. 2000, the ages were what? Positively or negatively skewed? Yeah, definitely. Negatively skewed, indicating students were, you know, more towards the upper end. More students were... Sorry? Yeah, you could say that. But the students were generally older in towards the upper end of 0 to 18. Do you know what I mean? They were more clustered. Well, look, 75% of them were 8 to 18, were negatively skewed, indicating more older children. For example, you could say 75% of the children were between 8 to 18. Do you know what I mean? But in 2010, the ages were, what do you think? Positively or negatively skewed? 875 kids there were positively skewed. So that's your skewness. We're positively skewed, indicating a younger, children were older. Children were younger, sorry, were younger. More children were younger. Or a higher percentage of younger children in the population. That's what I need to say. Indicating, you could say, a higher percentage of younger kids. Does that sound better? That sounds better. You could say, for example, half of the kids were less than 6. E.g., 50% of the children were 0 to 6. Okay? So that's skewness. Why don't we talk about median? Also, the median in 2010, is it higher or lower? Yeah, look at median in 2010 was 6. Median in 2000 was 12. So the median in 2000 was a lot lower than in 2000. So median in 2010, which was 6 years, was a lot lower than in 2000, which was 12 years. Okay? Indicating a lot younger children now live in the area. Indicating more younger children in the area now. More younger children in the area. Okay? I don't know if I'd be talking about interquartile range, really. I don't think it's as relevant here. Okay? But I'd be really throwing the percentages in on this one. I think it's important, all right? But we need to talk about median. We need to talk about skewness. So what would be one possible implication for government planning as a consequence of this change in the distribution of ages? What do we need? More what? More younger kids, more childcare centres. Yep. And perhaps primary schools. But definitely childcare centres. But look, 3/4 of the kids are 12 and under, whereas only half of the kids were 12 and under 10 years before. Do you see that? So that's primary age kids. So, and perhaps primary schools. Okay, so I could put that, you know, that 75, that it's not just the 75%, but look how many more kids. You could actually work it out. So we could say, I could actually work out numbers. In 2010, I mean, alone, you could look at, there were 875 kids roughly in that from 6 to 12. That's mainly primary school age. I know primary school's 5 to 12, all right? Whereas it's, well, a bit more. It's more than 25%. Less than 25%, sorry. Before that. That'll do.
Yay.
All right?
Finished.
Good enough.